Inshallah, in today class, we are going to continue the exact differential equations. Sometimes the question will be not in exact form. We have to multiply with some integral factor to convert it into exact form. On that, we have to see few types questions are there. For the first type, let we do the questions on homogeneous functions. Let me do a questions on homogeneous function. Now, first understood what is homogeneous function. If the degree of the terms, all terms are same, then we say it is a homogeneous differential equation. For homogeneous differential, see here, I will give some examples. The degree is 2 here. Here x is 1, y is 1, 2 degree. The power is 2 here also, here also, here also, here also. So this all the equation has the same degree of 2. So we call this as homogeneous function. In the same way, here you see x square y, 2 plus 1 3. We said degree is 3. X y square, 1 plus 2 3. Degree is 3, degree is 3. Here also degree 3. 1 plus 2 3 3. So here also you see x square x square y square. So if we have the same degree of each term, x y terms, then we say that the equation is homogeneous. So for homogeneous differential equations, we have the method homogeneous differential equations. The method is we have to multiply with integral factor. Integral factor, the formula of integral factor will be 1 by mx plus n by. And generally we know that we should not have the denominator 0. So it is applicable only when denominator is not equals to 0. Denominator is not equals to 0. So whenever we get homogeneous function and it is not exact, so we multiply with this number to form exact. After multiplying this with this term, we'll get the exact form, and we can solve by using the previous formula for exact differential equation. We are going to do two questions on this type, inshallah. One question I will explain you in detail, and the second question, inshallah, we go in short. Now see how to start the question written on the board. First, let me see whether it is homogeneous or not. M dx plus n dy equals to 0. The value of m you write. The value of n you write. Now we already know that we have to check whether it is exact or not. For that, we have to find dou m by dou y, dou n by dou x. If these two are equal, we say exact. So let me see dou m by dou y with respect to y. So we do not differentiate x square, we write as it is. D by dy of y will be 1 into x square minus y square is 2y, 2 roots of 4xy. Now see here dou n by dou x with respect to x square is 2x, so 2 3's it will be 6xy minus x cube will be 3x square. Now what's this one? We don't have equal values, therefore dou m by dou y is not equals to dou n by dou x. Okay, so we have to change the method. Now watch here, just now we understood this is of the type homogeneous. Its degree is 3, its degree is 3, its degree is 3. You see all the terms are of degree 3. So let me find the integral factor. For homogeneous function, the integral factor is 1 by mx plus ny. 1 divided by m, the value of m is x square y minus 2xy squared into x plus n is 3x square y minus x cube into y. So multiply this one, it will become 1 divided by x into x square will be x cube y minus 2x into x square y square plus y into y will be y square, 3x square y square minus x cube into y. Sorry. Now see here once more. This is x cube y minus 2x square y square plus 3x square y square minus x cube y. So let me solve this. Plus 3x cube y minus cancel. What is left here? 1 by 3 minus 2, 1x square y square is x square y square. So if we multiply this integral factor with the given question, the question will reduce to exact form. Now let me see whatever we are having. The question is x square y minus 2xy square dx plus 3x square y minus x cube dy equals to 0. Multiply by integral factor. So let me multiply this all with, so actually this denominator, now we'll get this in the denominator, x square y by, we are multiplying with this, so we get this in the denominator, x square y square minus 2xy square by x square y square into dx plus 3x square y by x square y square minus x cube by x square y square dy. Now you cancel the terms. See here, we get x square cancel, y 1 is left, 1 by y minus y square cancel, x square cancel, 2 by x dx plus, cancel this one, left with 3 by y minus, if you cancel this one, you left with x by y square and dy equals to 0. Now again let me see whether it is exact form or not. Previously we kept here m1, let me substitute m1. Suppose we take m1 here, plus n1 dy equals to 0. Therefore m1 equals to 1 by y minus 2 by x and n1 equals to 3 by y minus x by y square. Now see here, we have to differentiate with respect to y, partial differentiation. So see here, we don't have y here, it will be 0. D by dx of 1 by x is minus 1 by x square. Therefore this will become minus 1 by y square. We have one formula, d by dx of 1 by x. This is minus 1 by x square. So similarly here see, dou n1 by dou x. Here we don't have x, it becomes 0 minus d by dx of x is 1, 1 by y square. Now you see we got the same values, we get the same values. Now it becomes exact. Therefore dou m1 by dou y equals to dou n1 by dou x implies exact differential equation. Now for exact differential equation we have the formula. Let me continue this from the top of the board. Now see here, let me use the formula. What the formula we have? In the previous class we already learned about this, integration of m dx plus m1 here and dy equals to c. Here we take y as constant, Here we take terms which do not contain x, So let me continue. Integration of m1 is 1 by y minus 2 by x dx. In n1 we have to take only terms which do not contain x. So this contains x, so we do not take this one, we take only this 3 by y dy equals to c. Now integration here with respect to x, we don't have x here, we are having only 1. So integration of 1 will be x. So this will become x by y minus, you write 2 as it is. Now integration of 1 by x, integration of 1 by x is log x, so I write this one as log x, plus you write 3 as it is. The integration of 1 by y dy 1 by x dx is log x, so this will be log y plus log y equals to c, sorry, c into, here we have 3 into, okay. So we can live here, or if you want to solve little more, you bring this, do one thing, bring this 2 here and this 3 here. We can write like this, x by y, I'm writing this plus log of y. If you bring this 3 here, it will be in the numerator, minus log of x square equals to c. Now log a minus log b is log a by b. We can leave the question like this, x by y plus log of a by b equals to c. We can leave the question in many ways. Also, we can solve little more, but we can leave here. So let me do one more question in short, inshallah. See here the next question. Now compare this. This is m. This is n. Now if you differentiate dou m by dou y, this will be 2y. And when we differentiate this with respect to x, x square is 2x, x is 1, 1 into y is y, constant is 0. These two are not equal, therefore this is not of the exact form. So because this is homogeneous equation, degree is 2, degree is 2, here also x 1 y 1 2, this is also 2. So we change by multiplying with integral factor. Integral factor is mx plus ny. M is y square into x plus n into y. You multiply this with y, x square y, x square x y square y cube. Now you get this cancel. X square y minus x square y get cancel. So what is left here? If you cancel this one, now take common from this to y. We get x square minus y square. So this is the integral factor. Now we multiply the question with the integral factor. Y square first term. So multiply with integral factor. Here also multiply with integral factor. Now this is m1 and this is n1. Again we compare. This is m1, this is n1. Y will get cancelled. What is left here? We left with y by x square minus x square. Now see a little bit we will change here. We write x square minus y square minus xy. Separate this, you will get cancelled. X square minus y square by y into x square minus y square minus xy by y into x square minus y square. Why we separated this one? Because this will get cancelled. You left with 1 by y minus this y will get cancelled, get this one. Now again we do not need to show that this is exact form. Always this will be in exact form. When we multiply it with integral factor, the remaining terms will always be in exact form. Therefore we can use directly formula without showing. Integration of m1 dx plus integration of n1 dy equals to c. In m we write the m, but we take y as constant. In n we take only terms which do not contain x. We cannot take this one because it contain x. You take this one, this does not contain x 1 by y. Now see here, integration of 1 by y will be log y. Now this you see y is constant here, so it is of the formula of 1 by x square minus this is constant, so you feel this one a square. 1 by, you write y outside, so what is left here? 1 by x square minus a square. We have the formula for this. 1 by x square minus a square is 1 by 2a log of mod x minus a by x plus c. So y into, we written the formula for this. 1 by 2 into a. A will be y. 1 by 2a. This is the form x square minus a square. So in place of a you are having y. 1 by 2a log of mod x minus a by x plus c. Now log y. When we get the answer complete in log, you write the constants also log c. Change the constant into log. When we get the complete answer in log, you keep the constant also in log c. In place of c you write log c. Now this 2 y will get cancelled. Bring this 1 by 2 in the numerator, in the here in the power, you'll get this formula as, so log a plus log b will be log ab. Log ab equals log c. Log will get cancelled. Now this is power half, means square root. To remove the square root we will do squaring. So if we do squaring on both sides, this root will go. What is left here? X minus y by x plus y. This will become y square and this will become c square. Now last step, bring this x plus y there. So we get x minus y whole square equals to c square into x plus y whole square. So today class we have learned how to solve the questions which are not in exact form but are homogeneous. So we converted into homogeneous, so exact form, by multiplying with 1 by mx plus n by. In the same way other type of questions are there, inshallah. We will continue that in the other class.